Hi, everybody. Welcome to Sanveo's webinar series. We are very happy to have Michael Malroney in our first webinar of the series. Michael Malroney is a registered professional engineer, mechanical engineer in the state of Illinois. He has a bachelor's in mechanical engineering and an MBA. He has about 3 decades of experience in his belt as director of engineering, focusing on new product development, design for manufacturing, and his latest experience has been with Skender as director of engineering, where he led setting up the modular factory. Uh, Michael, I would like to introduce you with those words and would like to hear from you about your experience in Skender, focusing on the modularization, if you will.
Sure. Thank you, Aruna. So I started with Skender a few years ago. Skender is a general contractor in Chicago with the vision to start up a modular manufacturing facility as a new division of Skender Construction. So the modular is Skender Manufacturing. The reason that they pursued me is my manufacturing background. So I do not come from a construction background. My experience throughout my career is engineering and particularly manufacturing. That's my passion. And Skender's vision was to set this up right and do it correctly, to do it as a manufacturing facility, rather than a modified sort of construction type arrangement. So I came on as director of engineering. We went to work right away on finding a location and setting up the factory, all the equipment, all the CapEx, everything that was required in terms of infrastructure and processes. So that was about a 1.5-year journey to get the factory stood up and ready to go into production. And then eventually we started producing modules. So that's how I got involved in this modular construction or modular manufacturing. And that brings us up to kind of current conditions.
Thank you so much for joining us today. Our webinar series, the first thing we wanted to look into was modular construction. There is a lot of buzz around in our industry in terms of modular construction, design for manufacturing, fabrication, sorry, DFMA. And then there is also a lot of buzz around off-site prefabrication for buildings, primarily because we all want to save money and time. No one better to talk about this. Our first webinar is titled Modular Construction Demystified. With your experience, we thought it would be extremely appropriate to have you demystify modular construction for all of us.
I'll do my best.
So with that, having said that, modular construction could mean different things for different people in the industry. For some of them, it's building blocks. For some of them, it's literally manufacturing in a controlled environment. For some of them, it's about just prefabricating kits in a different facility and bringing it to the site. For some of them, it's any process that can lead to savings and costs that is repetitive. What does modular construction mean to you? How would you define modular construction?
Well, the way that we set up our factory was, if you look at what you're making, which is a completed module. So we started with, we manufactured steel frame chassis, and that's kind of the first step in the process. And as you move through the process, what comes out the back door is completed, fully finished module ready to be stacked and stitched together in the field. So probably the distinction that I'll make is that we looked at that with a manufacturing lens and treated the module as a product. So versus, I think, some of the traditional modular is somewhat similar to constructing modules in a factory, where a lot of traditional construction kind of techniques are just simply brought under roof, and the modules are put together more or less by skilled tradesmen who do that sort of thing for a living, whether it's framing or MEP. In our vision, the module is just simply a product, and we hired semi-skilled labor. We developed our processes, so the production line is very simply assembling a product. Every factory worker had a very specific task to do. All of our infrastructure was in place, our drawings, our work instructions, our part numbers, our bills of materials. It was a manufacturing facility, not just assembling or constructing a module under roof, but really assembling as a product moves down an assembly line and comes out the end, goes through final QC, and then out the door.
It's very interesting because as a construction management student back when I was in school, first lesson we learned about project management was, well, every project is different, and 101 was management is different from process management. It What you said was very insightful because we're looking at developing buildings as in an assembly line. We're talking about building an assembly line for buildings. You're
Yes.
envisioning a building factory similar to a car factory is amazing. So on that note, like what would you call the fundamental differences between modular construction and traditional construction? What are some of the key differences?
Well, one of the obvious ones, Aruna, is modules are built in a factory rather than on site.
Mhm.
So I think a lot of that is very obvious to most anyone in the industry. Um, a lot of the real key differences lie in the preparation and the way that the factory is set up. And so by that, what I mean is that in a traditional construction site-built building, the initially architects and structural engineers are going through concept design and design development. Eventually you get a permit set of drawings and a construction set. That construction set of drawings goes out to the field, and again, skilled tradesmen are every day interpreting those drawings and going about their work back and forth between interpreting what is drawn in the construction set and how do you translate that into a building, and they know how to do that. That's their specialty, but it still requires a lot of experience and a lot of time on site to interpret the information that's in those drawings. With modular manufacturing, you flip that totally upside down, and you're not handing a construction set of drawings to factory workers. That's just not reasonable. So during those early phases, in addition to the architects developing the permit and eventually construction sets, we're also developing what we call shop drawings. And basically the shop drawings are very similar to if you're in an automotive plant, you've got very detailed product drawings, and those drawings show all of the information that's needed to assemble whatever is going on at that particular workstation. So very detailed bills of materials on the drawings, very detailed part numbers on the drawings, very detailed cartoons, the drawings themselves showing the placement of everything, the dimensions of everything, how to fasten, the quality control that is necessary, any additional safety information that needs to be on there. Drawings are supplemented by work instructions. So what goes out on the factory floor in a properly done modular factory is extremely detailed shop drawings. All of the interpretation that would typically happen on site in a traditional construction is done ahead of time in modular, and all of that information put into those shop drawings. So it really is a fairly significant lift as far as the amount of time and effort that it takes. If you can imagine moving through all of the framing, all of the MEP, FP, all of those details and all of the coordination that goes into it, all of the clash detection, everything that's done, and a lot of that's done typically, but still the level of detail that's in the drawings isn't there. They'll figure it out on site. All of that's done ahead of time, which really requires a significant effort up front, well before permit drawings are issued and construction drawings are issued. All that, what we call design coordination effort, is all going on behind the scenes very early in the project timeline.
And how do you think that, will that mean the architectural and structural design and drawings will have to be developed with a modular mindset, if you will, for lack of a better word?
I was going to use those exact words, and Aruna, that's exactly it. Is everyone involved has to come at it with a modular mindset, and I'll give you a very good example. One of the real advantages of modular is if you can imagine a multifamily, which is a real popular application for modular, multifamily mid-story apartment building. Those apartments, if it's site built, they can all be a little bit different, and you can kind of optimize space and make decisions on the fly, and they're to a certain extent, most of those apartments are somewhat unique. But in modular, to take advantage of the economies of scale and the efficiencies in a factory, to a large extent, you want those to be basically the same. So, for example, we were just doing a mid-rise for the city of Chicago, and I think there were 70 some apartments, but really only 4 or 5 unique modular types. So what that allows us to do is set up our production line and set up our welding fixturing, set up the production line, and run 25 or 30 of the exact same module. So time after time, and you really gain efficiencies that way. So to be able to do that, the structural engineers in the very beginning, the architects in the very beginning, they have to think through how to design the building and how to design the modules so they're not just similar, or they're not just mirror images of each other, but they really are very much the exact same footprint, the exact same module, time after time. And that's really where you gain a lot of efficiency, a lot of cost savings. But the first one down the line takes a little bit of time. By the time you get to the 10th one or the 15th, and you're making the same module over and over, you really gain a lot of efficiency, a lot of speed, save a lot of cost. But that starts on day one, designing with the modular mindset.
So we did talk about how everyone wants to save cost and time, but what are some benefits of modular construction? Yes, how do we save cost? How do we save time? How how do these benefits get realized when you take a modular approach?
Well, similar to what we were just talking about, uh, the more the modules are the same, the faster we get through the factory. So there's a few very obvious things. For example, there's no weather delays in the factory. So you can run 2 shifts. You can put out a lot of modules in a very short period of time. So it really does shorten up the time to get the 90% of the building manufactured. And the module is made, it's shrink wrapped, it's put on the back of a flatbed truck and put into storage. Once all those modules are made, then it's very simply truck them to the site and start stacking. Once the modules are stacked, there's a little bit of stitching together on site that needs to happen, but it's really not significant. So the overall timeline for the project is we estimate a 30% savings, which is very significant schedule, particularly for developers that are carrying the debt for 30% shorter time. There's also economies of scale in the factory. And what by that I mean is we're buying large quantities of material, and we can purchase direct rather than through distributors because we're using such large quantities of the exact same thing time after time after time. So there's, with purchasing agreements and other tools that a production facility has that aren't necessarily available to site construction, we can buy them in large quantities and put the material into inventory, store it, keep it, and we get lower costs on the material. So you pick up efficiencies through the factory in terms of timeline. You pick up economies of scale on the cost, and again, the more the modules are the same, the better that is, the better that becomes.
You can keep repeating it, rinse and repeat in one
Yeah,
sentence.
yeah. Wash, rinse, repeat. Exactly.
And I would also assume, because it's a much controlled environment, you're not going to have the obvious delays from, let's say, weather conditions and things like that.
Yeah, correct. It's 70 degrees and sunny every day, without a doubt.
That's very impressive. So, given your experience in the FMA, and also setting up the entire modular factory floor, what are some of the processes that you have adopted? Um, we're all yours to know what worked for you.
Sure. I would say most of the specific processes for us were taken from our manufacturing backgrounds. Again, treat the factory like you're manufacturing a standard product, because you really are. So for us, that started with beyond just the factory layout itself. It started with an ERP system that's designed specifically for manufacturing facility. So an ERP system that allows assignment of part numbers. So we, for every fastener, for every piece of steel, for every different type of jip, for every component that comes in the door, we assign unique part numbers, track that through our sourcing system. Everything has an inventory location. Everything is in a bill of material for that particular module. So we set it up exactly like a typical manufacturing facility, and that all kind of revolves around having a proper ERP system. In other words, the infrastructure, which also included HR and accounting and everything. It all revolves around having that right tool to be able to set up our internal processes. Beyond that, the shop drawing process that I was referring to earlier was fairly unique in that construction typically not used to that level of detail. So it's a different type of a drawing. It's an assembly drawing with sub-assemblies and component level. So on the floor, the assemblers can look at the information that they need for their specific task at their specific workstation. So we developed a process and a system for making those shop drawings and putting those shop drawings electronically out on the factory floor so everyone can see them and access them, access the bill of materials behind the drawing. That's kind of a little bit of a hybrid, I guess, but very effective for us. Another thing that goes with that is, as in traditional manufacturing, a document control system. So we issue a drawing to the factory floor, and if a stud has to move, or if there has to be a change, dimensional change, whatever the issue is, as done in traditional manufacturing, that drawing gets revised through what we call an engineering change notice system and reissued to the factory floor. So you're not coming back later and developing an as-built set of drawings. What you're putting out the back door is exactly reflected by the revision of the drawings that you're using to make that product, if that makes sense. And I'm sorry, go ahead.
I was wondering, specifically with quality control, I would assume you have a lot to tell us.
Well, the way that we designed our factory is basically we had 5 major workstations, starting with welding, the HSS frames, and then moving down the line through MEP installation, walls, chip, and eventually FF&E. And then the last workstation was simply a quality control station. So we developed a process working with the city of Chicago to, at each workstation, whether it was the welding or the framing, each workstation we had our QC documentation that was fully filled out, supported by pictures, all of it signed off. So each step had what we call the QIP document, which is a quality document, reviewed, signed off before and dimensional information in it. For example, a welded steel frame chassis, our target, most of them were in the neighborhood of 15 feet wide by 40 feet long. So our target using a laser measuring system was plus or minus a 1/16 of an inch in all directions, including diagonals, which is very precise. So we were able to develop our welding processes to meet that kind of dimensional criteria, but then we had to validate it. So we used a laser system to make those dimensional measurements, document in our QC documentation, and move forward The same with all of the MEP. So by the time the module is done and on a flatbed, we've got our QC documentation for that particular module all signed off and filed.
That's moving from accuracy to precision in construction industry pretty much, and that's it's pretty impressive to hear the kind of processes that were developed to enable modular construction. But I'm sure in the process you've also had a few challenges. So do you want to tell us what were some of the challenges you'd faced?
Yeah, we did. It wasn't all completely smooth sailing. I would say, Aruna, probably the most significant challenge is earlier I was referring to the amount of effort that goes into developing our shop drawings, whether that's framing shops or MEP or what we call FF&E shops. Because they're done early and because they're so detailed, it's a very significant effort. A lot of man hours required to get to that level of detail and get through all of the clash detection and everything that has to be done to get the drawings completed. And what we found was that can't be left until the design is done. So if you think about a typical process, architects move through concept and they move through design development, eventually a permit drawing, and eventually construction set. And the design really isn't done until you get that construction set done. What we found is, and one of the most significant challenges is you can't wait until the construction set is done and then start doing shop drawings. It just, the schedule doesn't allow it, and it's too much effort too late in the project. So we developed a process where we moved the development of the shop drawings far ahead in the schedule. So we were actually starting on framing shops and MEP shops during probably 50% TD, which is really early. So you have to work that out with your partners. For example, structural engineers. They're not used to being that far along at 50% DD, but understanding our needs and understanding what we needed, that everyone put in the effort to accommodate starting those shops really early. The risk in doing that is when you're moving to DD, moving into construction documents, there's changes. So now structural engineers are going back and making changes, which affects the shop drawings. Same with MEP. So we found it's really important to get your trade partners and any consultants that you might be using for shop drawings, like Sanveo, for example, involved very early, so everyone's on the same page. So we were getting our trade partners, our MEP, involved way before they would typically in a typical construction project. So we're getting them contracted and getting them involved in development of MEP shops well ahead of what they were used to and quite frankly, what they were comfortable with. It really is taking folks out of what they're used to, taking folks out of their comfort zone. But we feel it's the right way, and the amount of rework that's necessary because changes are made it's there, but it's not that significant. The benefits of doing that way are greatly outweigh the downside.
Absolutely. You've given us a very nice picture of what modular construction is. You've kind of helped us remove those weeds and understand modular construction very well. What is the future that you envision for our industry from a modular construction perspective?
The future of modular, I think, is very bright. There's a lot of advantage to doing this. It really does remove a lot of the inefficiency of traditional construction. Modular has been around for a while. Started really with primarily modular homes and wood, but now there's a lot of very successful wood and steel modular companies out there, but the industry is still relatively in its infancy. It's not a mature industry. There's a lot to learn. There's a lot to do. A lot of tools that are being developed. A lot of expertise that's being developed. I firmly believe that down the road, whatever that timeline is, I don't know, but that this will continue to grow and eventually will become the preferred method for constructing buildings. It's not right for all buildings, but for certain types of multifamily type, hospitality, healthcare, schools, where a lot of the rooms are similar, and you can take advantage of the efficiencies that modular brings. It is absolutely the right solution, and I think the future is extremely bright.
Well, it looks like we have multiple types of buildings where we have a lot of potential for modular construction. Um, Definitely, with the experts like you leading the way, I'm sure our industry will head in that direction.
Well, thank you. I certainly hope so.
We really appreciate you joining us on this webinar, and we really look forward to being part of this modular construction revolution, if you will, in our industry. Thank you so much for joining us, Mike.
Thank you, Aruna. I really enjoyed it. I appreciate your time.
Thank you. We really appreciate your time too. Thank you.